Let's see here. Hello. Hello. Hey, Jen, how are you, my friend? How are we doing? Yeah, I was, stepped away for a couple hours, took a nap. You know, being old, gotta take a nap in the middle of the day. Feels good. Then come back, get all my head straight, refreshed. Mm, yeah, old man syndrome. Take a nap. Hello, hello, hi Gerda. Hello, Gerda. How are you? Pretty good. All right. Did you have a good week? I hope you had a good week, because it's been a whirlwind kind of week. I'm just saying. Everybody's kind of going up and down, all the stuff going on, and yeah, for the most part, good, 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 good. That's all that matters. If you're feeling good, that's what matters. There you go. Lots of respect there. All right. We're gonna be starting in a few minutes here, so we'll get going then. Um, yeah, I know I started the stream a little late, so we'll wait for a few more people to come on by, and then we'll get going. I'm gonna talk about systems of non-linear systems of equations. It's a bit important there. Hey, K Dog, what's going on, bro? How we doing? Andre, how we doing? How we doing, my friends? I hope we're doing pretty good. K Dog, Andre. Hey, JTS, my friend. My weekend was very good. Very fun. Very, very fun. Let's just say the past couple of days have been very crazy. Let's just put it lightly. Extremely, absolutely bananas. But in a good way. In a good way. In a good way. Seems seems I've been adopted into another lovely, lovely family, the hashtag family. I'm very happy about that. I'm glad to hear that, K Dog. Horse drawing. Oh my god. Oh my gosh. That horse drawing. You're never gonna let that go. You're gonna never let that go. It's the single worst thing I've ever drawn. I'm terrible at art. Ready to learn. There you go, buddy. I'm down with that. Yes. Ready to learn. I'm so down with that. My day is going very good, my friend. Very, very good. Um, I did the hashtag family art. Yes, they are. Yes, they are, K Dog. Absolutely. They're allowed to. They welcome me in with open arms, and I'm more than I'm more than thankful for that. It's a wonderful feeling when you have such positive energy going around. But you drawn a horse on the side of all your notes. Oh my gosh. So Andre, I did the old man thing. I took a nap in the middle of the day, and I feel super refreshed now. I'm like have all this bursting energy. And you just gotta do it. You just gotta do it. I'm like, yeah, you know, I'm like, yeah, let's learn. Let's do some stuff. Just do it. We'll wait a couple more minutes. A couple more minutes. We'll wait, see if a couple more people come in because I started the stream a little bit late here. But then we'll go ahead and get going, and then we'll get started here with stuff. With the stuff of legend. What's on today's agenda? Today's agenda is going to talk about non-linear systems of equations. It is the best feeling after a nap. That's true. And you know what the best part is? Let me expand upon this just a little bit. Okay. Do you see the top of my head, right? Do you see how there is a lack of hair on the top of my head? Brought to you by my father, my father's genetics. Um, the best part is about taking the nap is that you don't really get bedhead when you don't have hair to get bedhead with. That's the best part right there. You see, there's positivity all around. I'm telling you right now. See, I'm telling you, being yeah, oh yeah. You see, it has its perks. It has its perks, okay? It has its perks. Your hair's not going off in 13,000 different directions because you know when you get up off that pillow, there just ain't nothing there anyway. You know you hit the big time when you go into like a Great Clips or any haircut salon, and then your G's like, hey, just give me a number two all over. You know, you got number two all over. Takes 10 minutes. I'm like, here's $20. I'll see you in 3 months. Bye. That's how you know you're like, man, it kind of pays to be a little bit bolder. I'm like, I can save money that way. Sure, why not? Give me a number two with the beard trim. That's right. That's the best part right there. Just it's like, okay, it's like there, boom, got it. Best part is if I ever get bullied and my head gets stuck in gets put in a toilet, then at the very least I know that I don't have to fix my hair again. It'll smell, but I don't have to fix my hair again for the rest of the day. So you know, I would say there's a part there that I kind of like, Oh my gosh. All right. All right, we've spent a few minutes here. Okay, I think we got everybody in here in the chat. You know, no. Uh, no, fortunately not. I'm not gonna lie. 12 and having no hair, yeah. It does feel refreshing when you walk outside. You have no hair. I don't know. It's a thing. It's a thing. Uh, anyway, okay, let's get started today. Welcome back to Thursday. End of the week time today. This is the only time we're meeting this week. So, of course, last class we didn't meet because of election day, and EC said everything's closed, and it's like, okay, fine, no classes on election day. Fair enough. All right, but today let's go ahead and talk about what are we going to do here today. Today we're going to continue moving forward here in chapter 5. Um, we got section 5.4 and hopefully get a little bit of section 5.5. Just depends how fast we go. Um, We're going to be talking about systems of non-linear systems of equations here. Because if you remember what we did last week, we talked about systems of linear equations, about, say substitution, elimination, that kind of stuff. Today, we are going to talk about non-linear systems and how to solve for x and y in both of those cases. I know that sounds extremely exciting. Absolutely not. But okay, we're gonna give it a try. Okay, we're gonna give it a try. All right. Also, I did shave over the last weekend. I had to get rid of Mr. Fluffalovagus. So this is my unshaven face with a slightly bit of stubble until I decide to shave again. So you gotta. Sometimes it's just a little too much hair there, and it's like, that's also a non-linear system of process to actually get it all off. So, um, all right. Anyway, let's take a look here at number six. Number six, just a just a crazy day today. All right, I like it. I like it a lot. All right. You look like Dora? Oh no. Looking for those fresh math problems. Here they come, my friend. Here they come. Okay. I'm gonna get your fresh math problems right here. Yes, that's not good. Oh, now they're not corrupted anymore. Fine. Good job. Good job, computer. All right. So let's talk about number six. Number six is what we're going to be talking about here today. What is a system of nonlinear equations in two variables? All right. So let's go ahead and put up an example here of a nonlinear system equation of two variables. All right. So let's do that right now. Okay, so a nonlinear system in two variables could look like this. And again, there's a lot of different looks that we're going to use as examples here, because there are varieties of these type of problems here. So I'll put down one, and then we'll look at, say, another one. So we'll look at others here as throughout this particular section. All right, and we'll have this. Oops, that would be alpha plus. All right, 2x plus y equals 5, and then you have, say, y equals x squared plus 6x plus 7 would be the other equation. Now, these two would be of non a system of nonlinear system of equations. I keep getting that backwards. But here's just one example. Again, one or both of the equations could have, say, an x squared in it or an x to the third, whatever. Now we're only going to focus all the way up to, we're just going to focus up to x squared kind of equations here for every example. But you can see how this generally works, okay? You see you have, again, how do we encounter, or how do we deal with, systems that could look like this, and how do we solve for x and y? Now, I do want to point out one very, very important thing that we are definitely going to see in this section here in particular. So I do want to highlight this note here. Note, it is possible, rather more than often than not, it's possible, actually very often, that we can get multiple answers. Okay, so one thing you can take to the bank here is that you can get easily multiple answers in these problems. Okay, so we could have, say, two ordered pairs or three ordered pairs, four ordered pairs, whatever. We could have multiple ordered pairs of answers that would satisfy this system of nonlinear equations. Okay, so that's something that we want to at least be able to understand. So when you get to that and the final answer, you're like, why isn't it just one thing like it was in the last section? Well, it's because it's a nonlinear system. Okay. All right. So by and large, it's not like it's not like super hard, but again, I just want you to go in there with the expectation that yes, multiple answers is certainly a thing. And we're going to have to be a little bit extra careful about how we go ahead and approach some of these problems. Because some of these problems can be only done in a certain way. So we want to be able to we want to be able to see some of those examples and be able to do it in that certain way. So that's why last time we did substitution elimination, and you could do substitution, you could do elimination, and you could pick either one, and you could solve for x and y. Well, in certain situations, you can only use substitution, or you'd feel that that would be much easier. And in other situations, you could use, again, elimination, because that would be much, much easier, for example. So if I took a look at this example that I put up here for the nonlinear system of equations, then I would say in this case, this particular case, I could say, oh, okay, I could use substitution in this case. That will be significantly easier than that of elimination. Okay, let's go ahead and take a look about why that would be here in this case. All right, so how do we solve for a nonlinear system by substitution? All right, so let's put the big key here for using substitution. So to use substitution, it should be clear that you can solve for one variable. It should be clear that you can solve for one variable here. All right, and that elimination would be more problematic. So in this case here, as you can tell, we got y is equal to x squared plus 6x plus 7. So it should be pretty easy to see and be like, oh, okay, hey, I got x squared plus 6x plus 7. So I can plug that into, say, the y into the first equation. Well, that's a lot easier than just saying, all right, let's just try elimination every single time, because it's going to get messy really, really quickly. Okay, so if it's more problematic, then, then fine. Then it's going to be like, okay, let's use substitution. And sometimes that may be the case. I'm not saying for all cases, mind you, but some cases like this, yes, substitution by far is the easier method by far and away. Okay, so just understand the distinctiveness here between both of those things. Now, having said that, let's talk about how to solve this using substitution. Okay, and again, I'll talk about the steps here. The steps are the same as they were in the last section. Okay, so the steps are exactly the same. Okay, no difference on how we do those steps. Again, we're going to solve for one of the variables, then we're going to substitute, we're going to solve for the remaining variable, and then solve for the other variable. I would be reiterating myself from what you have in the notes from previous. There is nothing going on that I'll be doing anything that would be different here in that regard. Okay, so let's take a look here, though, at this problem. And not be a dumb. Yes, yes. Painting tool is paint. All right, that's good. Good. All right. So here we got 2x plus y equals minus 5. We got y is equal to x squared plus 6x plus 7. Okay. Now, step one is pretty much done for us, okay? We basically say, all right, let's just solve for one of the variables, all right? So we solved for y because y is equal to x squared plus 6x plus 7. Yeah. So here, let's start off with step two, since pretty much that's done. So we're going to take this x squared plus 6x plus 7, and we're going to plug it into the y into that first equation. So we're going to have 2x plus, now this is also very important here. Remember, anytime we substitute, we put parentheses around what we substitute. So be sure to remember to do that here in this case as well. Even though, like I said, it doesn't seem like it matters a whole lot, it would if this was a minus sign here in the front, and then we'd have to distribute the minus sign to all three terms inside the parentheses. So again, because the sign changes, always make it a good habit to go ahead and plug that in with parentheses in there. You'll get less of it wrong because of the fact that you can take into account the sign changes. All right, let's add this together here. We've got x squared plus 8x plus 7 equals minus 5. All right, now let me ask this question here. Can anybody tell me here, what would I do next here in this situation? I want to be able to solve for x. So what do you think I should do next in this situation if I'm going to be able to solve for x? Okay, very good, my friend. That's correct. Add 5 to both sides. Totally agree with that. So let's add 5 to both sides here. I think maybe if you see what you can see what's probably going to happen next. It's not, it's not like too hard to see what will happen next, but still. Um, so here we get x squared. Okay, so we're here in step 3 now. So we got x squared plus 8x plus 12 equals, the important part here is that it's equal to 0, right? All right, fair enough. All right, now what do we do? What do we do next? How are we going to solve for x here? What do we do next? Factor. I agree. What does this factor to? X squared plus 8x plus 12. What does that factor to? 6 and 2. All right, totally agree. So let's factor this to x plus 6 and x plus 2. So if we solve for x here in this case, we're going to get two answers for x. We have x is equal to minus 6 and x is equal to minus 2. Okay? So again, this is one of the cases where we say, all right, hey, multiple answers are certainly a thing. I'd be like, okay, that's definitely true. Okay, so here they are in this particular case. Now, what we want to do here is solve for y, but remember, you're going to get two distinct ordered pairs for your answer here in this instance. So let's talk about how we can get that. So we have minus 6 and minus 2. So now what we want to have happen here is, let's use either one of the two equations. You could use either one of the equations here. It doesn't matter. You could use the first equation. You can use the second one here. Again, you want to be able to solve for y using either one of the two equations. I say in this case, we have y is equal to x squared plus 6x plus 7. Let's just use that directly. Let's see what we get. Now, actually, I should put it this way. Hang on a second. We're going to have two different answers for y depending on which x that we choose. So we have x here is equal to minus 6. So let's go with that one first. So we have y is equal to minus 6 squared plus 6 times negative 6 plus 7. Okay, and what do we get here for that one? What do we get here for y in this case? We get 7. That's correct. All right. So we get 7 here, so we get one ordered pair here is negative 6 comma 7. Okay, so that's one of our two answers here. Now let's look at the other case, x equals minus 2, and repeat said process. So minus 2 squared, 6 times minus 2, plus 7. All right, and what do we get for y here in this case? What do we get for y here? 15. Not quite. Not quite 15 there. Don't forget those parentheses there. That'll be a little bit important here. Minus 9. Not minus 9 either. Let's go through this here. Negative 2 squared is going to be positive 4. 6 times minus 2 is minus 12. Plus 7. That's why you don't trust the calculator all the time. That's why you trust what you see. That's why I write the steps out. 4 minus 12 is minus 8 plus 7, which is minus 1. See, the way you enter things in your calculator, see, that's what the calculator will tell you that because it depends on how you enter in the stuff in the calculator. That's why, number one, I put parentheses around whatever I put in. And that's why, number two, you don't trust the machine, you trust what you write and trust the process. You got to be very detailed when you put stuff into the calculator. Yeah, you got to put parentheses. The calculator cares if you put parentheses. Very much so. No parentheses equals no bueno. This I can guarantee you. Here, I'll give you a demonstration here, JTS. If you put this in your calculator without parentheses, and you put it with parentheses, if you put minus 2 squared without parentheses, it's going to think it's minus 4. If you put it with parentheses, that's positive 4. Big difference. Big, big difference. And totally throws off your entire answer. So you want to be very careful about that. And don't worry, Yeah, look, don't worry. I mean, a lot of people make that same mistake, okay? So, you know what? But you know, nah, man. Hey, good to see you again. Hope things are going well in Germany. Um, you're always welcome here, my friend. Sophros, you're always welcome, man. No, but one thing is that calculators, you can't just explain. Yeah, the machine will do what you tell it to do, but you have to tell it the correct way of doing things. As my old professor used to tell me, he said, he says, he's like, computers are dumb. He's like, computers are completely dumb. They'll do exactly what you tell it to do. It's like if you enter in something exactly the way you want it to, and it spits out the wrong answer. I said that's a you problem. That's not a machine problem. So I'm like, oh, I see. that I understand now. He told me that with computer science. I'm like, hey man, stick around. Learn a little bit. Have a little fun. All right. So here we get our two answers. Our two answers here is negative 6 comma 7 and negative 2 comma negative 1. And those are our two answers for this problem. All right. Any questions? Any questions about that? Nope. All right. Okay, let's go ahead and try another type of problem here. Which one do I want to do? Yeah. Okay. All right, let's do another type of problem here because there are several types of substitution type of problems. So we're going to have to discuss about those. Whoa. Okay. Blap, 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 blap. Okay. Okay. Nonlinear systems of equations there, Safras. This was an example with multiple solutions. JTS. Look, we got two solutions here, right? -6 and 7, -2, comma, -1. This would be an example of multiple solutions already. But pretty much most of the questions here will involve multiple solutions of some variety. So, oh, no. There are questions that could have more than two. Like that's true. Well, we'll definitely do possibly one of those. But in this section here, we're not going to be dealing with like infinite solutions or no solution. These particular problems here are going to have a solution of some variety. Okay, that part is true. All right, so we're not going to make it super complicated here, but we are going to be able to find solutions for all of these problems here. So when I'm talking about, say, multiple solutions, though, more along the lines of, for the examples that we'll look at, will be along the lines of saying finding a finite number of multiple solutions as opposed to an infinite amount. We already looked at the case about what would happen for an infinite solutions case. And the same thing would hold even in a nonlinear system. You'd have like the situation of like 0x squared is equal to 0, and then you'd have an infinite solution case. So it actually doesn't change. Yeah, no problem. No, it's a fair question, though. It's a very fair question. All right. Now, there are a couple of these problems that I do want to do here. Now, you're not going to like this next problem because it's another look, though. So let's do it. Oh, that was the wrong one. Sorry. Copied the wrong thing. Okay, gotta do that one. All right, there we go. All right, so we have xy here is equal to -12, and we have x minus 2y plus 14 is equal to 0. Does the degree determine the number of solutions? No, not always. It's a fair question though. Like with the zeros, you could think that you'll get two solutions, but not in every case is that going to be true. No. You actually have to do it out to see how many solutions you get. So, yeah, they're not necessarily correlated. They are in some way, but again, it doesn't guarantee that yeah, but we're going to look at an example where that's not the case. So, but a very fair question there, Planet. Yeah, so nonlinear systems kind of break the rules a little bit because of you're throwing two things kind of together. But that's why we meticulously go through it, so make it easier on ourselves at the very least. All right, let's go through the steps here in this case, okay? All right, so In a way, they're related, but I'm not going to expand. I don't want to make things more confusing than they need to be. Um, they're related, but maybe not in the way that you think. So I don't want to. I don't want to make things too hard. I want you to like be able to process and get to that result. Um, in that regard. So for the sake of not confusing you more, I'm not gonna like. It's a little tough to kind of explain. For the sake of doing that, I'm not gonna like super expand on it too much here. Okay. Yeah. If I feel that if I told you the answer, then it's like I could give you the answer, but I'm not gonna. It's just like an added thing that that would make it worse, and I don't want to do that. And it's like a minor point that essentially it's like more important to do the process than it is to worry about that one little factoid that may or may not matter. Gotcha. Yeah. So I'm not trying to withhold information. I'm just going to be like, oh, there is a reason, there is an answer to your question, but yeah, let's not make it too hard on yourself. But if you want me to tell you after class, I'll be more than happy to. So I don't have a problem with that. What's with my shirt? Is it a club or something? Yes, this is the shirt for hashtag United. All right. If you click on if you have some emotes there, um, you can up the tags, the bam. There you go. Up the tags. I'm part of the hashtag family. There you go. United Horses. United Horses, indeed. They say ignorance is a blessing. I suppose so, but I'm not. I'm not. I'm not gonna say that. United for Trump. Oh Lord, here we go. Uh, this is the election that will never end. Not until every vote is counted. So I bet we're not gonna find anything out for another week or two. So all right, election. It's been an election year. I mean, you've. Yeah, it's gonna be like an election 2 weeks. Election month. Yeah, that sounds right. Elections are still important, though. I hope you guys were actually part of the voting process. Right? Yeah. If you're Sophros, if you're here on the ground, yeah, there's a lot of stuff that goes on in the election every 4 years. Like it's pretty nuts. So, especially this year, due to the current political climate. Now, I'm not getting in too much into politics here. I don't care who you vote for or who you voted for at the end of the day. That's a you personal thing, and I will respect your opinion either way. Uh, the only thing is everything was very polarized this year. So yeah, I'd say that's very accurate, JTS. Very accurate. Very different side of people come out every 4 years. I'll state it. I'll state it before, like I've stated it before, but I guess I'll reiterate it again, and that is to kind of uh, reiterate is like my hope is that after this is all done and whoever wins, um, uh, we hopefully get back to the process of being the United States of America and not just the state of states of America. So you know, we're united. That's the most important part. So I'm hoping we get back to that. That's very important. But I'm not here to make it a political discussion, so. But that's my hope after this is all over and done with. Yeah. But let's focus on the positive things. There are things that we could do to hopefully, help each other out. This is my way of doing things is teaching the class and hopefully sending positive vibes your way, and doing fun things together, with doing math and stuff. You guys come out to these streams all the time, to hopefully better yourselves at the end of the day, and I hope to be the best facilitator as much as possible in order for you to get there. And if I do that, then I'm doing my job, and I'm pretty happy with that. So I would never complain about that. I would do them if it took a million of those horse drawings, I would do it. So if it got you there, I would do a million of them, no problem. All right. Let's take a look at step one here. We got to solve for a variable, ladies and gentlemen. So, which equation, well, a million horse drawings. It would be pretty bad, but copy pasta a million horse drawings. All right, so which equation are we going to solve? Which equation should we solve for, and for which variable? Horse drawings equals united. All right, let's get back to it, guys. Which equation should we solve for, and for which variable? Which looks the easiest? If we're going to use substitution here. Would it be the first equation or the second equation? The second would be easier. Okay, so let's use the second equation here. And which variable are we going to solve for here? So let's use x minus 2y plus 14 equals 0. Which variable should we solve for, x or y? For x. Okay, so let's solve for x here. So if we're going to solve for x here, let's go ahead and do our regular old rigmarole. We're going to add by 2y here. We'll also subtract 14. So I get 2y minus 14 here is for x. All right, so that was the first step. We've solved for one of the variables here. Okay, now if you tried elimination, by the way, for this, you wouldn't fare so well, by the way. Just pointing that out there. You tried elimination, how could you eliminate anything when you have x times y? Now, it would actually be fairly more difficult, to be perfectly honest. So one thing that we have to be careful about is, again, uh, that's why substitution in this case is by far and away the more preferable method. So that's why I chose this second problem here for that question. Now we're going to take this 2y minus 14. We're going to plug it in for x in that first equation right there. Okay. So let's see what we get. So we get 2y minus 14 in parentheses times y equals minus 12. I know it's weird. I totally understand that. Okay, so we're going to distribute the y here to both of these terms. So we're going to have 2y squared minus 14y equals minus 12. All right. So that's what we have here so far. All right. What should I do next? Add 12 to both sides. Okay, cool. All right, so let's see what we got here. You got 2y squared minus 14y plus 12 is equal to 0. All right, now as was pointed out before for the first example, we went ahead and factored, okay? We could make this problem a bit easier. How can we do it the lazy man's way here? That's an easy way to make this problem even easier. What do you think I should do? Divide by 2. Yeah, you could divide by 2 or factor out a 2, whichever way you want to go. That's perfectly fine. As long as if you divide by 2, then you basically divide by 2 everywhere. So yeah, you could do that. Balance always. So here we're going to get y squared minus 7y plus 6 equals 0. So that sounds like a plan. Totally agree with that, JTS. All right. Now, we could factor this. This is a lot easier to factor. What does this factor to? Y squared minus 7y plus 6 equals 0. What does that factor to? 7 and minus 1. Not quite, my friend, because 7 times minus 1 would be minus 7. And I'd need minus 7 on the outside. I need two numbers that multiply to positive 6 and add up to minus 7. So you kind of got that a little backwards. Minus 1, minus 6. That's correct. So here we have minus 1, minus 6. All right, so just like so. Okay. So let's see what we get here for y. So for y here, all right. Y here is going to equal 1 and 6. So we have two solutions here for y. Okay. All right. Questions so far about that? Nope. All right. Good beans. Let me check that here. Okay. Just making sure. Okay. Let's go ahead and find our values for x in each of these cases. So let's first start off with y is equal to 1. I just had to check another problem there really quick. So again, you can use either one of these two equations. You could use 2y minus 14, or again, you can use xy equals minus 12. Whatever you feel would work here. I guess we'll just use the x equals 2y minus 14 since we directly get our answer here. So one less extra step in all honesty. So here we get 2 times 1 minus 14. So x here equals minus 12. All right. So we get the first answer here will be minus 12 times comma 1 if y is equal to 1. Here we get y is equal to 6. So x here is equal to 2 times 6 minus 14. So x here is equal to 12 minus 14. So x here is equal to minus 2. All right. All right, and there we go. We got it. Any questions about that? There are two answers for this problem here. All righty. Okay. Okay, that's fine. All right. Let's go ahead and do the next problem here on the handout, which is the last one. Actually, it's give me just a second here. It's a little warm in here. I'm going to turn on the fan. All right, there we are. All right. Let's go ahead and get rid of this. Boop, boop. All right. All right, let's do the next problem here. Next thing on the handout. So the last question here. How do we solve a nonlinear system here by elimination? Okay. So how do we solve a nonlinear system using elimination? All right. So the key here again is once again is to use the same steps from the previous section. This is to be used on non-linear systems. Used on nonlinear systems with that have both equations having a square in it. Okay. This is typically used on nonlinear systems that both have having a square in it, and that's pretty common here for a lot of these problems here. Let's go ahead and show off a problem here, a problem or two, and we'll see exactly how we can do this with elimination. Okay. Again, just think about how we're going to conduct ourselves during the elimination process. So let's do it. All right, let's do it. I like purple a bit better. All right. What do I want to do? There we go. Got it. Okay. All right, so let's take a good look here. We have x squared minus 4y squared equals minus 7, and we have 3x squared plus y squared is equal to 31. All right, now, if you take a look here at both particular equations, both of them contain a squared term, again, x squared or y squared. This would be a good idea to go ahead and use elimination and then proceed to solve for both x and y. All right. Okay, we'll make a, do I have to make that note later? Yeah, I'll make that note later. All right. So let's go through the steps here on how to do elimination. Step one, we have to choose a variable to eliminate. All right, so let's eliminate x or y. So I'll let you guys take the helm here. Which variable should I eliminate? Should I eliminate x or should I eliminate y? Y. All right, let's eliminate y. That's what you've chosen. That's what we're going to run with. All right. We chose y to eliminate. All right, fair enough. So if we chose y to eliminate here, we have minus 4y squared up here, and we have y squared on the bottom here. We're going to do the same thing. We got to multiply one or both the equations by some numbers so we can get the opposite coefficients. All right, that's correct, JTS. Absolutely. All right, completely 100% agree. We'll put that in nice pink. Okay. I'm not even sure if you could see that, but we're going to put minus 4 right there in pink. Yes. To represent, I don't know what it represents. Something. Things. Okay, so let's take a look here at what happens here in step number 2. Okay, so we're going to have x squared, what did I put? Oh, oops, sorry. I put minus 4, didn't I? We'll put plus 4 here. Yes, all right, there we go. All right, so we multiply by 4 here, so we're going to get 12x squared, all right, plus 4y squared equals 124. Okay, so this is what we have here so far. Now we're going to add straight down. So the minus 4y squared and 4y squared, they cancel each other out. Exactly what we're looking for here. Here we get x squared plus 12x squared. That's going to be 13x squared. And then over here, we're going to get 124 minus the 7 here. So that's 117. Just like so. Yep. All right. Let's go ahead and divide by 13 here. So what's x squared equal to? 117 divided by 13, what would that be? 9. Okay, good. And what would we do next? How would we solve for x here? Square root of both sides. Okay, that's good. That's correct. So let's take the square root of both sides. Now, I know the square root of 9 is super easy. Okay? I know the square root of 9 is super easy. But I have to add this note in here because in this case here, square root does play a rather big role at this step. All right? Let's talk about actually a note here. Plus or minus is in play. Okay? So both answers here, both the plus or minus answers, when we take the square root, is in play for these problems. Okay? So square root of 9 is not just 3. No, no, no. Square root of 9 is now officially changed to plus or minus 3. Okay? So I want to state that here, this note here, because of the fact that, remember, I'm not sure if I mentioned this before, but some concepts with square roots, again, have only the positive answer to take into account, and some concepts with square roots take both answers into account. So I usually make this note here just to be on the safe side, that you guys know that when you go through this process, you're like, okay, I have to take both the plus answer and the minus answer into account, and I have to do it that way. So it's like, all right, because if you don't, then of course you're going to be missing an answer there. All right. Okay, any questions about that before we move on? We're not quite done just yet, but still pointing that out there. No? Okay. Now, this does have this little note here that I've effectively put, has a little bit more far-reaching consequences later on in this problem. Let's take a look at that next part here. We have two answers here for x. We're going to start off with x is equal to 3. Let's just start off with that and see what we get for y. So I'm going to use, I don't know if it doesn't really matter which one you use here. So let's say I use this second equation here. All right, so I have 3 times 3 squared plus y squared equals 31. Now 3 times 3 squared, that's 9 times 3, that's 27, plus y squared equals 31. We'll subtract by 27 on both sides. So we got y squared is equal to 4. Okay, so by and large, the algebra here isn't too hard. Now, once again, because plus or minus is in play here, we take the square root of both sides. Y here is going to be plus and minus 2. But let's not forget one very important thing. This was with the idea of x equaling 3, okay? And because x equals 3, here we get two answers for the price of one with one value of x. So in fact, we get 3 comma minus 2. And we also get the value here of 3 comma 2. So both of these ordered pairs are answers already, because that deals with just the first x that we found here from the first part. Now I just repeat the process here with minus 3. So let's do that here. Now if you repeat the process with minus 3, well, you're going to get the same exact stuff. In fact, all the numbers are the same, because you put minus 3 in parentheses, right? Talked about the value of the parentheses here earlier on. Well, this is another value of the parentheses here. You get actually the same exact answer for y. So we could go through the process here, but I'm just going to cut the mustard and get through that. So we get 2 and minus 2 here once again. Same steps, same numbers, same everything. And in this case here, we get minus 3 comma 2 and minus 3 comma negative 2. So this is the example I'm kind of referring to here, where in this particular circumstance, we get 4 answers here in this particular case. Okay, not just the standard 2. So this was asked earlier, where do we get more than 2 answers? Well, this is a prime example where we definitely get more than 2 answers. We actually end up with 4 answers here because plus or minus is in play here for all the answers for x and y respectively. So we want to be able to do that there without too much trouble. All right, any questions about that? Nope. Okay. Nope with a period. Is like, I get it. It's a miracle, but I get it. All right. I can imagine the choir singing behind Gerda right now as she's like, I get it. And then he's like, oh, just right behind her. The whole choir goes off, you know. All right. All right. So that's one example there. Let's go ahead. A choir accompanies me at all times. You are angelic, Gerda. There you go. You're angelic. Always the choir, all the time. I respect that. I respect that. uh, all hail Cthulhu. Is this a cult? Is this a cult? Yes, yes, we're all in this quote unquote cult together. the we're in this mathematical. Now it is, yeah. I forgot. By signing up for this course, you automatically check the box of giving me authorization of um, affiliating yourself to being in a cult. That's all your rights and possessions, they all belong to me now, and we must all honor our faithful. We must all follow our faithful guy here, Cthulhu. You know, I goodness, 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 goodness. I mean, we could all follow the yes. If we all follow, the Church of the Flying Spaghetti Monster, we can go with that as well. All right. We can all touch his noodly appendage. All right. The Flying Spaghetti Monster is amazing. All right. Pastafarianism, yes, absolutely. We can all be Pastafarians here. All right. Absolutely, 100%. Um, and we get tax exemption because of his noodliness. You know, just look at that sauce. Look at that sauce right there. If that doesn't ooze, um, if that doesn't ooze righteousness, I don't know what does. God. All right, all right. I just need to stop here. Oh, okay, okay. Oh my goodness. All right, true beauty. Yeah, mwah, there you go. that's right. Mm. And this is how an entire mathematics class did slowly become a complete cult, honoring Cthulhu and the flying spaghetti monster simultaneously. All right. All right. Oh my gosh. Oh, that's hilarious. Okay, let's do let's do another example. Oh my gosh. All right. Woo. All right. It's just one of those. It's one of those days, ladies and gentlemen. It's one of those days. I just know it. You gotta like it. You gotta like it. Let's try this next one here. If the Greeks can do it, so can we. That's true. The Romans were like, hey Greeks, we took over your stuff. We'll just adopt your gods though into our lore. Here we go. We'll just slap some new names and we'll call them the same thing. All right. So here we have x squared plus y squared equals 25. X minus 8 quantity squared plus y squared equals 41. All right. So which variable are we going to eliminate here? Let's what's that called again? Yeah. Let's excommunicate a variable. All right. Copy the homework, but just change a little bit. I remember I copied a whole project out of an encyclopedia, and I got 100%. So I'm like, okay, fine, if that's what you asked for. Word for word, I took it all out of the encyclopedia. That's right. Look, my greatest triumph was English class when I was a freshman at U of I. I knew you were a fraud, and I say credit. I know I'm a total fraud. Total fraud. Yes, absolutely, 100%. Like English class freshman year, I wrote an entire paper on monster trucks and aliens, okay, and Nostradamus, and I got a B. I just like made half of it up, with some sources that I just kind of pulled quotes out of, and I got a B. So I'm like, okay, whatever. Why? It was the part of the project. You had to make up some kind of topic, so I'm like, I'll just roll with this, and it worked. It worked. My mathematics degree isn't compromised. 1 plus 1 was fake the whole time. I'm a totally fake professor with no master's degree. Remember, English class is completely subjective. So there's no objective things when you write an English paper. I don't know how much time that a teacher actually takes a look at the paper. They could read like one or two paragraphs and you're like, okay, fine. I'm just going to give it a B. I'm like, okay, fine. What am I going to care? If you're going to read like two, because there's like a stack of papers a mile high, right? There's a stack of papers like literally a mile high. And if you're a teacher, all right, think about it in your shoes, right? If you had a stack of papers like this high, okay, are you seriously going to read everything? Yeah, you're going to seriously read word for word. Are you out of your mind? I mean, there's no way you're going to read all that, all those papers, word for word. You're going to skim through every single one, and then you're going to subjectively put down a grade, and then it's like, there you go. I gave a presentation of a book I never read. I got a C. I was like, okay, fine, you give me a C. It makes no sense. Essentially, you're just writing it to a particular person of the crowd. So if you write it to what the teacher likes, they'll probably give you an A. You write it the way that they like to read it, then they'll give you an A because they're like, oh yeah, okay, this looks great. I like it. So you got to know your audience. If you ever pass an English class, it's always about the audience, and the only audience member you have to care about is the teacher, uh, him or herself. So just figure. All you gotta do is if you're gonna run the racket, all you gotta do is figure out what exactly that they like to see. So you just get a ton of feedback on the first paper, and then write every paper with that feedback for the rest of the semester. Yep. Take that feedback, or again, ask the professor, or and just say, okay, hey, how can I make this paper better? They'll give you a bunch of stuff. Do it exactly the way they say. Okay, fine. Get your good grade. Then you'll figure out for the rest of the papers what exactly that they're looking for, and then just tailor it to what they like. Done. So if your entire grade is subjective, at least model it to the person who actually cares, which isn't you. See, easy peasy, lemon squeezy. Problem solving 2020. That's right. That's right. Yo, this so this is coming from the fake professor. Okay, fake. Quote unquote fake. the fake professor. Though I can I can attest that I did buy notes once for 20 bucks when I was at U of I. Those notes really helped out a lot. I will tell you that. It was right above a bookstore too. They were just basically selling notes for 20 bucks. And I got the whole semester's worth of history notes. And then I basically used that to basically pass the class. Was totally worth it. I didn't really go to many lectures that semester. Look, yeah, I made some choices that probably aren't the best choices, but I learned from those choices. Focus on what you're supposed to be an expert on. That's right. That's pretty awesome. If I can fake a whole career, we can do it for 4 years of college. That's right. That's right. Apparently, I can fake an entire career. See, you're learning adaptability. This is good. A very healthy conversation. This is good. I like this. Don't cheat stuff you need to. Yes, 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 yes. Honestly speaking, I can I'll cop to only I only cheated twice ever. I'll cop to cheating twice in terms of actual things. I cheated in 8th grade. Yeah. I cheated once in high school, but it was only for one problem. So I cheated in middle school in 8th grade. Okay? I cheated in middle school in 8th grade. And you guys are gonna laugh if I tell you what I cheated on specifically, because I didn't really cheat. I really didn't cheat. I only cheated those 2 times, and I cheated on the this. There. That's what I That's what I cheated on in 8th grade. Well, the thing was is that the answers for the test were all on the teacher's desk and it was right in front of me. So how could I not memorize the answers was the question. And in high school I cheated on. Yeah. Yeah, I cheated on music, can't discriminate. Very nice. Um I cheated on a history test in high school for one question. Okay. So I cheated on a history test in high school for one question, just one. And I believe the answer to that question was it theology or theocracy? I know it had a theo in it. It's like a theology or theocracy. I was like so stuck on the problem for like it's like one of those problems where like yeah, you get it wrong and it wouldn't matter, but when you're fixed on it for like 10 minutes, you're like I have to answer this otherwise I'm going to go crazy. So, yeah, and I'm just like, okay, you know what? The teacher walked out of the room. He's like, yeah, I'll trust you to hand in the test there once you're done. And once he walked out, I'm like, I gotta look at the book. I need to see. I need to check. I had to do it. So I'm like, am I confessing all? I'm confessing the 2 times I've cheated. Confessing to cheating. And then I could confess to stealing one time in high school. The only thing I've stolen was the only thing I stole was a 25-cent biscuit roll because I had no money. I stole a biscuit roll and some butter, and I was like, I need to eat some lunch, and I have no money. So, yeah, I just stole a biscuit roll. I bet they didn't care. It's like a 25-cent biscuit roll, so yeah. Honestly, those are the only things I've ever stolen. Did I cheat in Japan? No. Nah. Stolen biscuit rolls taste better? What the heck? Oh my gosh. Yeah, don't steal anything in Japan. It's really bad. And what would I cheat on? My job was to teach English in Japan. Would I cheat on would I cheat on English? I mean I'm not writing a paper. uh yeah, if they catch you cheating, yeah, cheating. If they catch you stealing in Japan, like even if you steal a candy bar or something, yeah, and you get caught, yeah, you can basically get your butt deported. So it could be like $1 candy bar. You'll get deported right away. So they'll just take you back to the airport that says get the heck out. So once somebody left a bag of chips, see that's not stealing though, because somebody could voluntarily left a bag of chips on the vending machine. That's fine. That's fine. I don't mind that. Okay. You are that's recycling. If somebody left something there waiting for you to take it, then that's okay. Okay. You know, if you tried for 5 seconds to find the owner and there's no owner around, okay. You can then claim ownership. Okay. If it's for a small thing like a bag of chips. If it's for a big thing like a wallet, yeah, I'm gonna try and return that stuff. So what is this stream? The stream is trying to get through a problem, but we're talking about cheating and things. That's fair. Oh goodness, no. Girl, like his mouse broke. How? How? How does a mouse break? you you sh- you keep you keep shouting at the mouse until it finally snaps. Yeah, that's fair. I remember getting like at least how many packages did I get off of the vending machine? I got like 8 packages of like chips from the vending machine. Because they were like 7 of them like all stuck together to the front of the vending machine because there's one of those spin ones. And so I got it. I got like one of the I bought like another like couple, and then they all dropped to the bottom. I'm like, yes. Thank you. Thank you, free food. I would say so, yes. That's a very fair thing to say. All right, let me go through this problem here real quick. Oh God. Oh my goodness. That's hilarious. What is going on in their heads to combine? Let me show you a clip here. Let me show you a clip here. All right. All right, this is from the movie Maximum Overdrive. If you've ever seen the movie Maximum Overdrive, then this will be a fairly familiar clip to you. Probably one of the more famous scenes of the film. It's an 80s movie, by the way, just to let you know. Okay? So I'll give you some context here. Let me see if my settings are off here. Nope. Okay. Here we go. Let's play this clip.
The one. Yeah, the kid that grabs his butt. Is that like mini Emilio Estevez? Where did you get a mask from? His bike is navigating too? I would just climb on top of that shit, right? Oh, fuck! Fuck!
Yo, I took a strike.
Oh man, yeah. Maximum Overdrive was an amazing movie. Yeah, right. Remember, ladies and gentlemen, Diet Coke kills. Um, literally. Here we go. All right, got it. All right, got it. There we go. Okay, I gotta finish this problem here. This will be our last example here for today. So, yeah, let's do this. Let's do this. Let's do this example here. I will eventually get around to doing this example here. Um, okay. So here we're just gonna multiply by -1 here. Gonna eliminate the y here. So we're getting minus x squared minus y squared equals -25. Well, that's right. There's more than one reason why you should never buy diet of anything, but that's just one reason. Diet drinks are so bad for you. I mean, heck, if he actually bought the diet Coke, and he drank it, I mean, still, what's inside the cans is just as bad. Um, here we're going to eliminate the y's here. Okay, so we're going to get minus x squared plus x minus 8 squared equals 16. All right. That's right. All right, you will have to expand here x minus 8 squared. So you may encounter this type of problem here, x minus 8 squared. So that will expand to x squared minus 16x plus 64 equals 16. Okay. All right, and then we go ahead. We can see that the x squareds cancel out. Very convenient. We'll take minus 16x plus 64 equals 16. Subtract by 64. All right, and so here we get minus 16x equals minus 48. Divide by negative 16. So x equals 3. All right. All right. So we got one answer here for x equals to 3. So we're going to possibly end up with one or two answers. Let's take a look at what our two answers for y are going to be. I have a feeling we got two answers for y. So we're going to use the first equation here. Oops. So we're going to have 3 squared plus y squared equals 25. So you get 9 plus y squared equals 25. Subtract 9. You get y squared is equal to 16. Take the square root of both sides. So y here is equal to plus or minus 4. So we get two answers for the price of 1 here. We get 3 comma 4 and 3 comma minus 4. And that's our final answer for that problem there. So that's another type of problem that you can certainly do that can be just as helpful in that circumstance. So, so you can see here that we have, again, substitution elimination there and how they work for nonlinear systems. All right, let me hang on, let me get a picture here. Let me get a picture here. Let me look at that one here. Yeah, let's look at you know, the best vending machines in the world are all from Japan. Those are the best vending machines in the world. You can't go wrong with the Japanese vending machine. By far and away, the best. You know. Uh, 7-Eleven in Japan? Yeah, 7-Eleven is very good in Japan. 7-Eleven has their own bank in Japan. People think that 7-Eleven is like just a convenience store here, but I will tell you this, 7-Eleven has a lot of purpose in Japan and is extremely good. And again, it even has its own bank. It's the only 24/7, 365 ATM in the country. Japan's kind of weird about ATMs, guys. Japan's ATMs actually close after a certain time every day. Here, I'll show you a picture here. Probably you guys have seen the Japanese vending machines at least once. And you can't ever find a trash can. Trash cans are, yeah, it's tough to find a trash can. But one thing that is nice is if you have a vending machine here, all right, typically next to vending machines or at least off to the side somewhere is typically you'll have, like, if you see on this picture here, actually, off to this side, you see this blue bin here. That's a recycling bin right next to the vending machine. One of the customs in Japan is to never drink and walk at the same time. So typically people drink next to the vending machine and then to recycle it next to the vending machine. There's also trash cans at the train station, since most people use that. Train stations on the platforms, along with specific bins for types of trash and recycling. So people follow that pretty regularly. So, and the best part about vending machines in Japan is they have both hot or cold drinks in the same machine. Why we don't have this here, I have no idea. But hot and cold drinks in the same machine makes so much sense. It makes so much sense that it's criminal that we don't even have it here in the United States. Absolutely criminal. I mean, look at this. Cold, the blue is cold, the red is hot. I mean, look at that. Same machine, hot and cold drinks. Like, why? Vending machine shooting hot ramen, right? Attack of the vending machine. Like, I don't get it. I don't get why we don't have this. Why do we not have this? Okay. Why must we have a very poor vending machines in this country compared to this? Look at this variety. I mean, my goodness, you can get a coffee, hot coffee out of the vending machine, okay, in a can, right? I don't understand. I just don't get it, man. All right. All right, ladies and gentlemen, that is the end of section 5.4 here today. We're going to do section 5.5 and possibly 6.1. We'll get move into chapter 6 as well. But that will take care of a section 5.4 here for today. I want to thank everybody for coming out here for the stream once again here today. You guys are all amazing. All right. All of you really, I have a lot of fun with you guys. Just kind of shooting the breeze and learning a little math along the way. So hopefully you learned a little bit here on the way. Okay. But again, thank you everybody very much for coming along here today. You guys are amazing. All right. Everyone have a very wonderful weekend. JTS, you have a wonderful weekend yourself, my good sir. Um, everyone have a very wonderful weekend. Stay safe. All right. Stay healthy and stay sane during these times. Okay. Please take care of yourself. Again, if you guys got any questions over the weekend, please feel free to email me. Okay. Yeah. You have a wonderful night yourself. Okay. All right. Have a great weekend, everybody. And we'll see y'all later. Have a great one. Take care. All right. Bye.